welcome to the second lecture on natural language processing. Today we are going to talk about history of natural language processing. As we have seen in the last lecture, NLP is a field which aims in building the human-like intelligence on the computer. It focuses on the interaction between computers and humans using some kind of natural language. And as we see, the goal of NLP is three. One is understand the natural language, how human understand the natural language. Similarly, we try to understand, we make sure that the computer understand the natural language and interpret the natural language the way the human interprets or beyond, because right now what we have is the data. So the system should understand the data and interpret some kind of understanding on how human language works, and finally generate the target language or the human language as similar to how human naturally do. Right, and it combines intelligence from computational linguistics, where linguistics again is a very important factor to understand how language works, and using that understanding some kind of interpretation and generation will be done by the machine. So we use some of the techniques like machine learning, deep learning, and other state of the art techniques to do this kind of task. Now, before getting into more deeper into the understanding on how the system does this thing, let's also understand how the NLP research came into the place and what kind of changes happened over a period of time. Because NLP, I would say there are lots of ups and downs in this particular research. So the understanding on how it began and where it began helps us in understanding how it gradually increased in the terms of fields as well as the goals of NLP. Okay, let's start with 1950s. I would say this is the era where the NLP research has actually started to come to the actual field of research. So starting with Warren Weaver. He would be called as the father of machine translation. In his memo called Translation Memorandum, which is written in 1949, which actually kind of uses the information theory to make sure that these theories will help the machine to translate from one language to another language. So his ideas are rooted in information theory. Especially during this time when the Second World War is happening, people started sending secret messages from one place to another. So to decode that secret messages, they started using computers. And information theory played a very important role. So with that idea, Warren Weaver proposed that language is a kind of code, how we are having a code of secret messages. Similarly, language is a code. When we can convert that code into another code, that means converting from one language to another language is also possible, how we are encoding and decryptizing the secret codes from the messages. So his idea is well celebrated, and lot of people started thinking about why can't we build a system, a computer system which understands the human language and converts into the target language. So I would say the first NLP application which is being used and attempted to build is nothing but machine translation. So 1950s, the machine translation emerged as one of the first major application, igniting significant interest in NLP. And I would say that was the period where a lot of research in terms of improvement in technology happened. People started moving on building different kind of computer system which go beyond building the calculator. And at the same time, there are a lot of other research in linguistics are also coming up in a very fruitful way. So, the initial systems that are being built using these machine translations are very simplistic, and it uses rule based kind of technique, and it uses the dictionary to look for the source word and its equivalent into the target word, and it uses some kind of basic word order to understand how the target language works. And in 1954, the most important Georgetown experiment, which is done by IBM, is one of the most remarkable journey in the field of machine translation. So, this is the first publicly demonstrated machine translation system happened in New York's headquarters. So, during this time, 49 carefully selected Russian texts are being translated into English, and with only taking in the domain of chemistry, and people started looking at the research on machine translation with lot of astonishment. Oh, it is possible right now to translate a text from one language to another language. And at the same time, in 1957, how much technology has improved, the similarly linguistic field has also improved a lot. A big revolution in the way people look at the language as a science has changed. So, till then, language is called as a language is analyzed through some kind of structuralistic view. Look at the language as a set of grammar, and this grammar decides the language. But after that, 1957 onwards, with the work by Noam Chomsky on his syntactic structure, he started revolutionizing the idea of generative grammar, where language is not just set of rules, and it is being generated by the human being, and this set of rules are the very basic things, but human generated it through different kind of means. Every human have the innate knowledge of how to generate a language. So, this is well structured in his book called Syntactic Structure. So, rule based machine translation is one of the outcome during those period. So, the rule based system, as we just mentioned, it actually takes set of words from two languages and try to map these two words between languages and generate the target language. Just by showing the example here. So, there is an English sentence, English phrase which is called the red house, which we need to translate into Spanish as la casa rosa. So, but when you look at the actual dictionary, the dictionary lookup says that okay, there is a definiteness or a determiner which is called the, and the equivalent is in Spanish either it is il or la. Il is used for masculine determiner and la is used for feminine determiner. But at this stage, the system will not know who is the next neighbor. Based on that, it may decide or it may not decide in the rule based technique. And red is translated as rosa and house is translated as casa. Now, the simple word order rule between English and Spanish shows that English always the adjective precedes the noun, right? You will say the red house, but we will not say the house red. Whereas in Spanish, it's always noun which is followed by the adjective, like it will be noun plus adjective. So, the red house now is being used using the dictionary lookup as la rosa casa, and there is a reordering of words which shows that the transfer rule is wherever there is an adjective followed by a noun, convert it into noun plus adjective. So, finally, you are getting la il casa rosa, but it should be la casa rosa because rosa is a feminine noun, right? So, the dictionary lookup might help us with a simple word ordering will help us to achieve this kind of output. Now, what is happening in this kind of research is the output that we get from the machine looks like there are a lot of semantic barrier. It is not able to generate the text similar to the target language, right? So, now what happened during 1950s and the late 1950s, most of the governments across the world started realizing the importance of building automatic machine translation tools. So US government started pouring a lot of fund in developing that kind of system. So they realized that it's possible to build a fully automatic machine translation system. Then after looking out the output of different machine translation system, they realized that it is not that easier to translate from one language to another, even though both the languages are cognitively similar languages. That means both the languages are sister or the very neighboring languages. It is not that easier for us to straightforwardly map one language to another language. So soon after that realization, government started actually formulating a committee called ALPAC committee. So this committee is nothing but Automatic Language Processing Advisory Committee. So this ALPAC committee started looking at the output of translation, and it made a statement that it is not possible to build any machine translation system in the near future. This statement came in 1950s. Though the recommended statements in ALPAC shows that we can still use these machine translation systems for as a kind of helping aid for the translators, but it is not going to replace the human. But during 1960s and 70s, still the research were happening in building some kind of prototypes, though a lot of research actually been stopped. So the continued development of rule-based system is one of the example is Eliza. So Eliza is a kind of program that mimicked some Rogerian psychotherapist. It's a kind of conversation between two different people. One is a psychotherapist, another is a normal human being talking to that Eliza. So it marks like how a psychotherapist work. So the original program was described by Joseph Eisenbaum in 1966, and it is implemented in 2005 later. So for example, the exam given here, you could see Eliza is asking the person, is something troubling you? And the person says, men are alike. And Eliza says, what is the connection? Do you suppose? Eliza you say, they are always bugging us about something or other. So Eliza asks, can you think of a specific example? Okay, the discussion still continues. You could see there is some kind of chat between the man and the machine during 1960s. And how is it happening? Those days there are no machine learning, there are no data science, like well developed data science research, but we are able to build a kind of human machine chatbot, and this chatbot is completely done using some simple basic regular expression technique. So there are some pre-coded information. From the pre-coded information, the conversation starts. And once the human provides the input, using that input, some kind of pattern matching happen, and the question is being actually framed. So that's the one successful story of how chatbots are being built in during 1960s, where the exact research on NLP is being completely stopped by government. So during this time, how do they test the efficacy of this kind of machine? So the benchmark for machine intelligence is required. These days we have benchmark data set to test against the NLP model. Similarly, the benchmark for machine intelligence initially started with Turing test. So most of you might have known about what is a Turing test. So this Turing test is nothing but it's a test between two, there are two players, player A and player B, and let's say player C is the interrogator, and the human interrogator asks several questions to the player A, which is a computer, and player B, which is the human responder. So based on the answers, the interrogator, that is player C, attempts to determine which player is a computer and which player is a human respondent. If the interrogator is able to identify, distinguish between who is the computer and who is the human responder, that means the computer system actually failed. If he cannot distinguish between a computer and a human responder, that means this computer actually succeeded in its action. That means it's able to work like a human. So, during that period, the benchmarking is being, Turing test is being used as a kind of benchmarking. Though later people find out that there are some issues with the Turing test, because it's completely based on the chat between the interrogator and the computer and the human responder. There are a lot of high chances that the human bias, that means the bias on the player C, might also show off in the output. So, people still find it some issues, but this would be the best benchmark model used during this 1960s and 70s. So, as we have seen, this LPAC report actually played a very important thing on machine translation. It has shifted the focus on the research on machine translation. So, US government stopped it and evaluated the computational linguistic research as an impossible research during this time. So, we could call this particular time as AI winter time. That means it's a period which reduced funding and interest. Since there is no funding for this kind of research, the research is also been stopped, and only a few research happened here and there around the world. And then what is happening in 1970s? Despite all the slowdown in NLP research, during 1970s, a significant advancements were happening in computationally tractable theories of grammar, because it's very important for us to make sure that there is a development happen both in the language science period as well as the information theory field. So, both computer and linguistics growth is very important to build a better NLP system. So, during this halt in the funding, actually a significant advancement happened in the understanding of language grammar. So, it started with case grammar by Filmer. So, he developed a grammar which focused on understanding the role of noun phrases and their relationships to verbs, and he has provided some kind of framework for understanding the sentence structure and the semantic roles. Semantics is nothing but the meaning role of each of the noun phrases within a given sentence. So, this gives us an understanding on how human language worked. And similarly, semantic networks are becoming very popular research. So there are graph based representation of knowledge started coming up, because the knowledge graphs is nothing but understanding the knowledge and the relationship across words and sentences in a given language is very important. So during that time, from the linguistic point of view, semantic networks become very popular. And similarly, conceptual dependency theory is another work very popularly being used to represent the semantics, not only the structure of the sentence, but the understanding the meaning of sentences in a structured format is being emphasized. So, all this research played a very important research for the later period of NLP research. So, then in 1980s, we could call it is a period of expert system. So, lot of symbolic approaches are known as expert systems are dominated in 1980s of NLP research. So, here not only hard-coded rules, some kind of ontology, because 1970s gave an idea on how to use different kind of semantic knowledge in automatizing linguistic or language information. So, these knowledges are being converted as some kind of important knowledge resources for building the machine, not only machine translation, different kind of NLP application. So these ontologies are nothing but knowledge bases which contains facts, concepts, relationship within a domain. So these domain informations are expressed in a very structured way, and these informations are really helpful to infer what information a language actually is referring to. For example, if the system knows that all humans are mortal, and also there is a sentence, Socrates is a human, it can easily infer with these two information saying that Socrates is a mortal, because Socrates is a human and all humans are mortal. It entails that okay, Socrates is a mortal. So this kind of knowledge information, graph information comes through the ontological knowledge. So 1980s are the period where the system started using this kind of expert knowledge into the application. Okay. So from the late 1980s to early 1990s, there is a transition from the expert system to statistical model. So this shift, we call it a symbolic to statistical modeling era. So this started replace the expert system. These models started looking at the language as a data. Okay, there are a lot of information in the vast amount of data. Instead of creating hard bounded rules and building models to understand these rules, why can't we derive the rules automatically? So that paved the way to understand statistical modeling is one of the possible ways. So now machine learning, the idea of machine learning started becoming into the root of NLP during these early 90s. So statistical model utilizes different kind of machine learning, because here we need to learn the pattern that is there in a language and rules also automatically, instead of writing the rules as a manual coded information. So this marked a significant shift in NLP research and application. So nowadays all our research in NLP is centered around making sure machine learns on its own from the data what we give, instead of writing more and more cumbersome rules, right? So there is again an advancement in computational resources also. So in late 80s and late 90s makes our computational power of the computers becoming very, very more powerful. So it facilitates the first RNN, recurrent neural networks, that are being built during this time. Though it's been built, but it is not vastly used for any application, but the machine learning can be dated back to early 1990s. So during 2000, it is the best period for NLP, we could say. So there is an increased use of neural networks. These neural networks are a kind of replication of how our human brain works. There is some kind of connection across items in our brain. So similarly, they are started replicating the same thing for language understanding and generation. So they initially applied for language modeling. So the focus of neural network is predict the next word. So looking at the word, what could be the next word that can be predicted. Okay, that is being actually done by neural networks. So word embeddings become very powerful, because just looking at the word as a set of phonemes, set of sound units, instead look at the words that they have some kind of mathematical weightage. Okay, so this weightage are nothing but trying to understand words are represented as dense vectors. Okay, that means each word will have their own unique vectorization. So words with similar meanings are mapped with similar vector representation. So this proved that there is a very clear understanding and relationship across words in languages. So for example, when there is a word like mathematics and statistics, when there is a similarity across these words, the word vector, the vector identification number, but both mathematics and statistics look similar. Similarly, lion and tiger. So, this is not only helping us in grouping the similar kind of semantic representation of words, it also helps us in predicting what would be the word which is similar to the other word. For example, if we have a king and if we have a vector for man and if we have a vector for women, using this, the understanding what would be the vector for queen is possible, because from the king you subtract man and add the women, that provides us the queen. So, now word embedding clearly helped us in deriving an understanding of the relation across words using this kind of weightage. Okay. So, this gives us a different scope. Okay, so there is some kind of relationship across words that can be logically derived through the mathematical weightage. Now, there are a lot of challenges even in this word embedding, because it struggles to efficiently learn word representation, but often when it is worked with a small text corpora, that leads to suboptimal embedding. So, we need now more and more data to make sure that the system learns proper embeddings from the data. So, the best success during that period is 2006 is the period where Google released the Google Translate, which is first commercially successful NLP system using some kind of statistical method. So, it utilizes statistical models for automatic document translation. So, now the impact of word embedding didn't stop during that time. So, people started working on how to use this word embedding knowledge to build a vast, use this one on the vast amount of data, so that we can build some kind of knowledge representation. So, the pre-trained embedding is another era where use the large amount of data, understand the embeddings from the data and keep it as pre-trained embedding, and any of the application that we want to develop will use this pre-trained embedding. So, that is how the pre-trained embedding used as a feature, and it improved the performance across various NLP tasks. Now, it helps us in understanding the text meaning, but the text meaning comes through the distributional semantics, that means understanding the word like embeddings. So, the common neural network, especially the dominant architectures like LSTM and CNN, are very, very popular during this 2000 era. And in 2014, Encoder-Decoder model become very popular, because this gives us another idea about there is a general formalization of sequence to sequence problem. For example, it is not only understanding the weightage of the words, but there is some kind of encoding and decoding of information from the data is important. So, Encoder-Decoder model helps us in converting the source. Let's say if it is a machine translation, it helps us in converting the source into a context vector, and from the context vector we are decoding the context vector into an output sequence. For example, if we take the same example what we have seen earlier, the red house, right. So, the red house now it's been encoded and converted into context vector using some kind of word vector representation, and now the decoder uses the context vector, not the source language. Now, using this it decodes and finally it is able to give La Casa Rosa in Spanish, right. So, now there is a success, people are able to see this encoder and decoder using this word representation helps us in getting the output. Now, after this period, now there is a very important period in NLP where transformers are being used. So, these attention mechanisms are very one of the welcoming thing that happened in NLP, which comes from the landmark paper, Attention is All You Need. So, it revolutionized NLP research by eliminating recurrent connections and relying solely on attention mechanism. because the relationship between words are not always to the next word, right? So there is some kind of connection of one word to the next word where it can occur anywhere in the sentence or anywhere in the document. So this, where to give the attention to, like in the place of that particular word is being done through using some kind of attention mechanism. So now it is capable of capturing long range dependencies and context efficiency. So for all these things, what we are end up doing is build large data. So now large data proved to be like providing us better performance across NLP task. Now there is an enhanced information flow because of this transformer when we are like implementing it in encoder and decoder system. So it improved the performance, and later on period we could see lot of improvement in like in the NLP field. So this led to the advancements in pre-trained language models. So people started training on large data sets because NLP is a data hungry field now. So it needs to consume too much of data to understand and get a weightage, get an attention on like how the semantics of a particular word can be understood. It can be done only through large amount of data. Now, transformers trained on vast amount of internet text in a self-supervised manner, and it led to the development of powerful pre-trained models. The pre-trained models like GPT, okay, the pre-trained models like Llama. So there are many more pre-trained models started coming into the picture, Falcon, okay, whatnot. So all these pre-trained models are now as nothing but a representation, weightage representation of language. Using these pre-trained models, a lot of fine-tuning is done. So fine-tuning is adopt that pre-trained model for a particular task. So that's how the fine-tuning is being done on the pre-trained language models, and it helps us building quick applications, and it's useful for new task and domain and other areas of NLP. So to sum up what happened in NLP field, as you could see from 1950s onwards, the research started. So it is not a new field anymore, right? But the interest during that time is only building translation. But the improvement in the research on syntactic structure by Chomsky and generative grammar led to the later advancement in NLP in terms of computational as well as linguistic understanding happened throughout the year. So each year, each decade is marked with some kind of improvement in the thing. So now right now we are living in 2020 plus years with a GPT, with large language models in our hand. So now, to sum up, NLP has evolved significantly from its early beginning, and it continues to be rapidly growing field, because we need to build more and more applications. These applications should replicate similar to the human generation. So I could say from 2002 to 2020s actually mark a very significant transformation because of neural networks, word embeddings and transformer models. These advancements enhance the ability to understand and generate human language effectively, and the ongoing trend is how to use this large language model increasingly so that we can build some kind of wider NLP application. So the future may involve more advanced pre-trained model, better understanding and more robust multilingual models, which is the most required thing for Indian context. So other than that, ethical considerations are very important because we are working with large amount of data. The data itself can have a lot of ethical problems, or the architecture may produce some kind of like bias, or the output interpretability may also end up in creating some bias. So the bias mitigation is increasingly important when we are working with like a large language models and NLP applications these days. So that's the like the next future tasks people are looking forward. So I hope this class might have given you a brief account on how the research on NLP started and evolved over a, almost some 70, 80 years, and right now we are standing with an NLP and large language models. And using these models, how are we going to use it in a more important way of building multiple applications for languages. Thank you.